Awesome. Right, I'm here to talk about sandboxing and my work in it. I am actually working on 2 projects relating to sandboxing. The first one is called GUADEC, which is an actual app that your distro will have eventually. It will let you run sandbox apps. It does installation, updates, and actually runs the thing. And in a very real sense, it's comparable to RPM or dpackage, although it does something completely different. But the other side is the GUADEC SDK, which is, well, it has multiple parts, but one part is the binary release, an upstream binary release of node that you can use to make apps. But it also involves just making our platform work in a sandbox fashion, like adding APIs and supporting it in the shell and whatnot. So I have 2 major goals in this work, and one of them is sandboxing. And sandboxing is, on a high level, very obvious. You want the app to be able to do less, and in particular, not do bad things, whatever that means. But I also want to revolutionize deployment and distribution of desktop apps on Linux. So I want upstream to be able to do a binary release of their thing, and immediately everyone on every distro and every version of every distro should be able to use it. And if it's shit, they should be able to delete it, and it should not have messed with your system. So the talk is about sandboxing, but it kind of doesn't make sense if I don't start explaining how the deployment stuff works. The distribution side, we're using something called OS3, which perhaps more people are aware of. It's a Git-like system for large trees of operating system binaries. It's usually used for full operating systems. In fact, the GNOME continuous system uses it for testing. But we use it for the apps. You don't actually have to know much about it, but in the end, an installed app is a checkout of an OS3 repository into a regular directory of files. So here's an example minimal application. It's just a hello world thing. So it's a directory with a certain structure. There's a metadata file that has configuration options for the app. There's a bunch of files that are the thing your app will require at runtime. So here we see a binary, some bundled libraries, and some text, some data that your app will require at runtime. There's also a separate directory called export, and everything that goes in there is exported to the system when the app is installed. So these 3 examples are typical things you see exports. There's the desktop file and the icon, so that you can show your installed app in the shell and whatnot. And then there's the debug service file, so that you can implement services, which is particularly important as we're moving towards debug activated desktop files. You could conceivably have other things here, like a GNOME shell search provider thing, similar things. Basically, this gets exported, and then we have the XDG directory thing pointing to this directory. So everything should pick it up by default. Here's an example minimal metadata file. It has a name, and the name is actually we call it the app ID. It's the same as the name of the desktop file. It's the same as the dbus name, and it's the same as the actual application name. The command is what we run when we start the app, and the runtime is kind of a dependency on something that the app needs to run. And here's a minimal runtime that are very similar to an app. This one is super minimal, has the shell and libc and the dynamic linker. A more standard runtime would have a lot of libraries in there. X libraries, dbus, a bunch of standard stuff. And also probably shared data, like themes and icons and fonts. Things that you expect everyone using this runtime, or mostly everyone, to use. It's very similar, it doesn't have the exports because you can't run it. So here's the command to run this and install it. At some point you define the remote as some URL to your repository, and then you can install runtime, install app, and then you just run it, and magic happens. It printed hello world. Could you imagine that? So under the covers, we're using something called file system namespaces. And they're kind of weird and new, but I like to describe them in terms of root. A lot more people are aware of what a root is. Take like a subdirectory or a mount or something and you root into it, pretending that the root is actually in this subdirectory. File system namespaces are very similar, except instead of a subtree, you get your own tree. So you can completely define how the file system looks inside your app. And we do this, and then we put the runtime files in /user, and your app files in /app. And then there's this bunch of scaffolding to make things work. It's not very interesting, it just needs to be there. The interesting part is this. This directory is always available, always writable. It's where your app is supposed to put its data. It's in your home directory, but that does not necessarily mean your actual home directory. It's just the same path name. Although in your actual home directory, it will be in this position. I'd like to talk a bit about runtimes because people have all these expectations. Something is called dependency, people get confused, think it's packages. A runtime is really no different from an app. It's just a split. The files could as well have been in the app itself. In fact, if you moved all the files from the runtime to the app, it probably would work. So anyone can make a runtime, but the question is, or who should? The reason we have the split, the reason you have a split in terms of packages is a technical reason. You want to have some way to describe the minimum requirements. But the reason we have this split is for ownership reasons. We want different people to maintain the two things. Because one is core, complicated, distro-like thing, which is the runtime, and we want to share the work in maintaining it and doing releases, and bug fixes, and testing. And we want to make the app developers do none of that, because we want the right people to do it. So we want as few runtimes as possible, because they're hard. And I imagine, I can't know, but the way I imagine things will play out is that we have two kinds of runtimes. We'd have the native ones, like I created the GNOME SDK, also a free desktop platform SDK, which are very useful if you're an upstream and you want to release your app as a sandbox app. It's all about sandboxing, it's all about doing all the stuff that XDG app lets you do. And it's likely that your app needs changes to work in this, at least if it's supposed to run in a sandbox fashion. But I also imagine there would be a bunch of transitional runtimes where you basically take an existing set of packages and pick some subset of it, call it a runtime. So maybe you would have the Fedora runtime, and then you can take all the other packages in your distro and make apps from those. So you just bundle whatever packages were not in the runtime in the app, and then bang, you have a bunch of apps. Obviously, these apps will not be changed, so they will not be sandboxed to use any of the new APIs. But it's still extremely useful. Not being sandboxed makes it less likely that they work across distros because they might be reading stuff from your file system or whatnot. But in practice, most apps probably works across distros, across versions of distros. So could still be very useful. So, back to sandboxing. Unix isn't Windows. We're already secure, aren't we? Why do you need this sandbox stuff? I mean, I update my machine, it's always secure. Well, maybe I don't always update, but historically, Unix security is all about users. You have a server that has often shared users, and you want to protect users from each other. You want to protect the system and the administrator from the users so that they can't own the rocks or attack another user. And generally, there's a single source or maybe two sources of software that you run on the machine. Basically, you have your distro, which you trust 100% because you're in the background doing updates that run scripts as root on your machine. So your distro owns your machine. And maybe you're running Oracle or something, but there's just a limited set of software that you run. But in these days, that doesn't quite match the desktop use case. You're generally one user on a laptop, and you're the administrator. I mean, you're not logged in as the administrator, but you're the guy taking care of everything on your machine. And you want to install random stuff. Someone tells you about this new game that's supposed to be really hot. You just want to download it and run it, not necessarily have it run scripts as root on your machine, but you just don't want to run it. So what we really want in terms of security is to protect the user from the apps. And this is not something that Unix historically has done at all. And by user, I generally mean the user's data and the user's identity. So you don't want the game to read your email or pretend to be you on Facebook or something. So you want the apps to have less access to your stuff. And you also want to be able to run some app that someone says is cool without having to have this deep trust in whoever provided the app. And if the app sucks, you should be able to remove it and not have it affect anything on your system. And also, in some sense, we want to make it hard as possible for viruses, botnets, and all that kind of bad stuff. So what kind of attack vectors does an app have on you? The easiest one is to read your files. You have your some things might be encrypted, but most things are not. Right? You can read your email pretty easily and all that stuff. But since we're using file system namespaces, it's very easy to just not let your app see any of your files. So you just don't make that visible by default. There's a bunch of traditional Unix security holes involving setuid and things like that. We avoid that by using no setuid mounts. We use no exec when possible. And there's also this weird process flag thing we set that basically neuters a lot of privilege escalation bugs. Many apps should never read to the network, read from the network. I mean, some will. I mean, if you're running a web browser or an email client, you expect it to run from the network. But if you're running a game, a single-player game, it should just not have access to the network. And there's this thing called network namespaces that lets us do this. So right now in XDG app, you can either have full access to the network or no access. And no access means it looks to you as if there's no Ethernet card at all. We also don't want your process to mess with other processes. You could send signals to them, send messages, trace them, and things like that. So there's something called PID namespaces, where we pretend as if your processes are the only ones visible in the system. You can't even see any of the app. You can't even see like host stuff like the real init or anything like that. There's also an IPC namespaces that give you a your own copy of all that's global in IPC, your own set of shared memory names and things like that. We also use C groups to group things, so we can limit like their memory and other processes and things like that. Also, it's very useful to give you an identifier for a process. So we give the C group a name that you can map back to the app name. And we use something called user namespaces to basically map every user but yourself to nobody. So if only your user is visible, you don't even know about other users available in the system. We expose very little hardware because that's generally attackable. If you have a hardware attack, either you can use it to get to the kernel, or you can like spy on you with your webcam or things that are generally bad. So the device nodes we have are minimal. We have device dev null, dev zero, but none of the actual hardware devices. We have a read-only sys and a limited proc that you can't tweak any of the knobs that are global. It's still possible to attack the kernel though, because the kernel is shared, has a shared syscall API with everything in the system. So if there's some kind of exploit in your kernel, it's probably possible to use that to get out of the sandbox. This is a very hard problem to solve. We're using something called seccomp, which let us filter out certain syscalls. So for instance, we limit use of socket types. So you can't use Apple Talk or any other weird things that are there. So if there's any bugs in those, at least we filter that out. But if there's a general kernel bug, then we just host. So it's actually very easy to set up a sandbox. The hard part is doing something in the sandbox, right? So you can compute and print results. That's not very useful. So we need to have a way to shoot holes in the sandbox. But it has to be the right holes. We can't just have random holes in it. So there's a way in XDG app for apps to request a less harsh sandbox. And right now, apps always get what they want. But the idea is that you have some kind of UI when you install this app wants full network access. Are you okay with that? And then you could either not install the thing or override its requirements. So we have the network namespaces that lets you give you network access. You have to opt in to have network access. You can opt in to have IPC, not have IPC namespaces, because that will allow you to use X shared memory, for instance, which is kind of useful for performance reasons. You can opt in to have the DRI device nodes. Those are supposedly safe, but who knows, it's hard or tricky to make sure that drivers are safe. You can opt in to have file access to your files. All of them, or just the directory, or just your home directory, or just your documents or your music files, things like that. And there's also a bunch of built-in services that we are able to grant access to. The first one is X11. So X11 has this socket inside 10, which is how you connect to it. So all we do is bind mount that socket into Sandbox, and now you can talk to the X server, and then you can do anything, because X is horribly insecure. I have this example here. I don't know if anyone can guess what it does. I can demo it. Does this thing also work?
Yeah. Yes.
Awesome. So I can run this, and it types evil. Oh, no. I'm sure you can imagine even more evil things to do. It just looks for all the terminals and prints stuff in it. It will probably find your root shell or your sudo available terminal and do really weird stuff. So basically, we can't ever. We can't ever use X and pretend to be sandboxed. But it's very useful because basically all desktop apps on Linux use X. But we have this new thing, Wayland. It's very similar. That's a single socket file you mount into the sandbox. It's in a more modern location in /run. But the cool thing is that the API and the protocol is based on this use case. So there's no way for any client to see any other client or any of their resources. In fact, it's really, really hard, impossible almost, to even have a window being a parent of some other parent. We have to fix the protocol to allow that. So this is the future. We're getting there slowly. I guess Fedora 22 might have a useful Wayland. For sound, we're using Pulse Audio. It's very similar. There's a socket you mount. You can connect to it, and then you can play sounds. But you can also record from your microphone, and it turns out you can also listen to all the other streams from the other apps, and you can load plugins into the server and all sorts of weird stuff. So we're looking at making that a bit more safe. I think Vim is looking at that. So maybe that will work eventually, and it would be possible to limit you. I think it should be sane for an app to be able to produce sound, but you have to have extra privileges to read from microphones, and you should never be able to load plugins into the daemon. We also have the dbus session bus. It's very important, in particular because we use it for activation in modern desktop files. But it's also kind of an open hole. So we only expose a filtered view of it. Whenever you start the app, you also start a user space proxy that filters all your dbus messages and applies a policy. And the policy is the same kind of format as the kdbus policy format. So eventually we'll switch over to kdbus, at least where it's available. And the default permissions is that you can own your own app ID on the bus and subnames of that. And you can talk to the bus itself, but nothing else. In fact, you don't even see any of the names that you're not allowed to talk to. It's like you're alone on the bus. Very sad. However, if anyone else talks to you, you can send one reply back to that message. So there's a flag in the message, like, is this supposed to have a reply? And if it's that set, you're allowed to send that. Optionally, you can ask for full access if you're just wanting to run some non-sandbox app. And the same with the system bus. We don't actually filter that because I don't think it's highly useful for desktop apps. It's mostly useful for the shell itself and the desktop. But we have an opt-in for that. You also probably want to have access to webcams and video streams. There's this new project that Vim is working on, Pinos. Another all similar to Penis. It's similar to Pulse Audio, but it's for video. Actually, it has some audio too, because they're often combined. I don't have this integrated in the XDG app yet, but I want to add that so that you can basically allow you some access to a specific webcam or something like that. So in this kind of setup, what would a good proper sandbox app look like? You probably still don't want it to read your files, because that's like this major open hole. So you still have your per app writable directory, You have Wayland access to do graphical output and user input, and also do sound output support. And you have a tightly filtered session bus access, and possibly network access depending on what kind of app you are. Still kind of hard to do anything. I can imagine writing a game on that kind of setup, but not read desktop app. So at the Hackfest, developer experience Hackfest a couple of years ago, we came up with the idea of a portal. And portal is not super well defined. It's a name for a design where you have a service that extends what a sandbox can do in a safe fashion. So you have something running in the session, or at least in some level of higher privileges that has access to something that sandbox apps don't. And then you have a protocol to talk to it, usually dbus, but it could be really anything. And the way you make it safe, I mean, exactly what safe means is kind of up in the air. I mean, is it safe to allow an app to draw on your screen? Depends on what you declare to be safe, but someone has to decide what is safe and make sure that your portals are safe. And one way to do this is to have them all be interactive. Like if you have an API that's like, I want the user to select the file. And then outside of your sandbox with zero control from the app, you have a full file selection dialog, and you can see all your files, and you can pick your file, and then at the end, you just send the data back to the app. Then you have a system where the app cannot misuse it to read random files, because that would show up random file selector in the middle of nothing, and you would just cancel it, or not select your important files anyway. And at the same time, if you do expect it to show up because you clicked open in your app, then the fact that you select this file is probably some kind of implicit grant of access to that file. So you're using the interactive portion as a way to avoid having to, ahead of time, declare what's safe or not. And the other way to do safety is to actually have the user declare ahead of time what each app is supposed to be allowed to do. And then we have the portal actually check the calling app. Is this app okay doing this? And in fact, Wayland is a portal. I mean, it was designed prior to this, but it's clearly designed from all these kinds of rules. It's safe to expose to any, as long as you consider it safe to be able to map windows, it's safe for a sandbox fashion. And Pinos and Pulse Audio is also safe, and we make them safe. But we also have XG app specific portals, and I think the most cool one is the document portal that I landed some initial work on recently. It's a way for your app to get access to files that are outside your sandbox. So basically, something on the outside of your sandbox uses this API, and it creates a document handle for a URI, and then it grants that document handle access to, grants an app access to that. So you can do, events is allowed to read and write this file. And then, by the magic of Fuse, that particular file and nothing else is available inside the sandbox app. So there's a Fuse file system mounted in this directory, so run directory, and this is the handle of the document, and that's the path name, or the base name of the file. So using this, you can then update the file, read the file, and delete it if you have permissions. And it's not just a mapping of the file, it's actually an API that's safe in the sense that writes to this file will not be visible until you have to close the file, basically. So you can do atomic replace, and whatever you write will not be visible outside your sandbox until you're fully finished with that app, or with that file. So you can, for instance, do partial updates and keep a file descriptor open while some other app is reading it. You can do atomic replaces and read a file. And then we have the content chooser portal, which is similar to what I talked about before, except the idea is that it has a wider sources of content than just files. I mean, you could potentially show you a webcam UI that lets you take a photo, or it could embed your photo library from some app and let you pick a photo simply. And then this all runs outside the app, and at the end we produce use the document portals to create a document for it, and we pass the handle back to the app. And that way it can load it, and it's basically safe for the same reason the file selector was safe. And I have an example here. So this is a sandbox version of events, where I replace the open call to just call the portal. So this is in the sandbox, and I click this. This is outside the sandbox. And I can open some file here, and it will load there. And everything looks to the user like nothing special happened. But in fact, like, I didn't fix the save as, so you can see if you try to save here, it's actually like some weird location where you can't see anything else. You can see the name of that particular file, but you don't know what directory it came from. You don't know what else is in there. And apparently I added a few other before, so there's a few things you can see, but not much. And in your home directory, there should be nothing. So it's empty, except it has the per app directory. So it should be safe in some sense. I mean, it now has permanent access to that particular file. In some sense, you gave access to it. I think that's fair. Oh. Yeah, so it's easy to imagine other kinds of portals we have. One common one is the sharing portal, where you select some content and you share it, similar to what we do on Android and iOS. It will show you something that lets you pick. Do you want to share it on Twitter? Do you want to send it in an email, or open with another app, or things like that? And there's also like low-level stuff. You don't want the full network manager UI or API in the sandbox. We have a mini portal that lets you see whether you're online or not. You want to have some kind of support for printing. I'm not sure yet how that would work. Maybe we run the print out outside. Maybe we do the queuing outside. I don't know. Alarms, wake me tomorrow at 5. Open this URL. I have a geolocation, show this in a map. Things like that. I'm sure it'll be, as we start making apps work in a sandbox fashion, there'll be more and more like tiny integration features that we need to look into and make work. The designer have like a page of stuff we need to do. And that's gonna be a lot of work getting that working. There's a couple of references if anyone wants to join. XD app has a mailing list, and if you want to talk about the GNOME specific stuff, I think that's done on GNOME OS list. XDG apps on free desktop, the GNOME SDK stuff is on GNOME. That's like the main web page right now. You can find everything from there. I guess that we should move that to somewhere else sometime. I guess that was all.
round, thank you.
Hello.
Hey.
So, how do you specify dependencies towards portals from an app? So, as to my understanding, the portals will be system-wide. You will have like one printing portal, for example.
Yeah.
And I installed the Sandbox app, and it will not function properly without the printing portal being installed.
Yeah, I mean, sure, and we don't actually have an answer to that, but in some sense, the way I think it should work is that a particular runtime somehow implies certain portals being available. So if you rely on the GNOME 360 runtime, that should imply some subset of portals being available. But we don't have any explicit mapping of that.
Can I just add quickly? So you didn't talk about manifest at all. So is that something coming? Do you understand what I mean?
No, not really.
So how do the applications specify which services they would like to have access to? What's the format of that specification?
So the metadata file is like the key value file where you can say, you can extend like debus things your access to and stuff, but there's no real declarations of dependencies on the host side right now.
It's not.
But for everything else, you bundle everything you need, and there's no.
It's not the Android model. It's the iOS model. When you need something, you're going to ask permission.
Yeah. So there.
Okay, so there's no plan to.
Yeah, I mean, you could conceivably do that on the build side, like have some framework so that you automatically pull in your requirements when you build your app. But
no, my question was simpler than that, but I think it was answered.
Yeah.
It's not the Android model where the user would allow access to certain services when you install the applications, but rather you try to design the portals so that they all have user interaction.
Yeah.
That's the only access control that actually happens.
Yeah.
Okay, thanks.
Cosmo?
Yeah.
Yes.
Do you have any mic bag? Here.
Do you have any idea about how the UI for things like Portal will look like at the end? Because right now, like, you kind of like open a file chooser, it's not like transient to the window because it's in a different process. How would that work with Wayland?
I actually have a thread open on the Wayland list for the particular case where you have wanted to make a process, or a different process transient to, or actually some other client transient to a window, and we're looking at extending Wayland to allow that basically.
Yeah,
but for the UI, we don't really have a design.
I guess more generally, like when you use like iOS, I feel that those dialogues are OS dialogues. Like you can see that they're not part of the app. So there's kind of like a fundamental, like a philosophical distinction, if you want.
Yeah, I don't think we want that though, because that's very like you're only running a single app kind of thing. It's not your traditional desktop where you have multiple windows open and they all run in parallel. I don't know. Ask Alan. Yeah, we have a fight tomorrow at dawn.
I have a couple of questions. The first one is about network access. You mentioned that you have either no access right now or full access.
Yeah.
So is your plan for partial access, like only these ports?
I mean, it's certainly possible with the network namespaces to do more complicated setups, but they are more complicated. You certainly have to have a firewall that interacts with a system firewall, and you have to have routing, and it becomes disconnected from the host network status so that you think you're always online because your local link is always online. So I don't have any good answers. I wish there were a better way to do it, but I think right now
practically, that's the only sane thing we can do.
My second question is, when you're talking about access to files through portals, you mentioned it done through Fuse. So how does that work exactly? Do you write to a separate file and do an atomic name, or like, because I'm wondering, because some applications require, say, a mapping of files or write large files in multimedia applications?
Yeah, so it's a Fuse file system. It does allow you to write a file next to it and then do atomic replace, or you can open a file, truncate it, and write. But you can't do in-place writes without a truncate.
Right, so I'm thinking like, also, and a lot of applications use SQLite, for instance. SQLite requires special access to the file. You can't do it atomic rename, etc.
Sure. But the idea is that the document portal is for documents. Yeah. Like your internal SQLite database would not be a document. It would be stored in your per app writable storage as any regular file. Yeah, I think there was one I asked before. Good idea.
Thanks for your presentation on this very interesting thing. It looks promising. I had a question with, it looks to me like some of the goals are similar to the one of kernel security drivers like Apamo, but I didn't really understand if it's linked to kernel security drivers or if it uses a totally different approach. And if you use a totally different approach, why you thought it would be better or more relevant?
Well, I mean, kernel security is generally on the level of UID. This UID cannot read this and a GNOME session kind of breaks if you start having every process run as a different UID. So I don't see there is any way we could use it without like heavily modifying what kind of security it does. I mean, potentially you could use as a Linux context for every binary, but I really don't see a way to sanely use the current security kernel extensions.
It's possible to kind of sandbox an application, a desktop application using Apamo. It's the only intakes for the Tor browser, for example.
Okay.
I'm not sure it's the best approach. I think the one you're presenting looks more easy to apply to lots of different applications, but it's possible.
It's certainly possible to use all sorts of kernel stuff, but having existing apps mostly work without lots of changes, I think it's hard. I mean, Chrome does all sorts of weird stuff when it's sandbox itself, but there was like a lot of work making that work. If you want to take any existing app and just run it, I don't think we can rely on that kind of customized work.
So, is the plan that when you build one of these sandbox applications, and then it would run directly on Ubuntu or SUSE or Debian or Fedora or whatever, or do you have to compile it on each one of those?
No, it should work. It should work. I mean, I tried to make a GNOME app and run it on Ubuntu and Fedora, and it works fine. I mean, depending on how much you expose of your host system, the more you expose, the more you risk that things are incompatible. So if you expose your home directory and you have some weird config file that doesn't really match what the runtime has for some version of your app, you could run into a problem. But in practice, it seems to work pretty well.
Okay, I think that's probably all we have time for in this session because the break's supposed to start. So that just leaves us with a speaker's gift, which you're going to be given now. So this is just a gift that all speakers are going to get. It's some tasty licorice.
Thanks.
I think he's taking care of the guy in the white shirt. He's handling the camera.
Oh, okay.
He knows.
No, but we have new cards now. Okay, and first up here.